What's up, people, and welcome to the 8th video in my Introduction to Distributed Systems tutorial. So in the previous tutorial we started having a little bit more look and diving into the code and the implementation of how the application is put together in JavaScript. And there is one assumption that we have been doing all the way through this tutorial. And I don't want to dive too deep into this topic because this is a really big topic in itself. So I just wanted to explain that this is like also a section in the program that you will have to be, consider if you want to build something like this. And that is the topology management. So like the term topology, what it actually means in our case is how do we know what IP addresses we have available to us? So if we use the second option in the menu here, when we print the topology, this is what we get back. Like we have the local host and we know what port to contact it in, blah, blah, blah. And when we bootstrapped the whole application, what we did was to manually send a ping request to one of the replicas. So we have to know the IP address of at least one server in the cluster. And this is how we deal with our implementation. And once one of the nodes receive the message, it will piggyback the IP addresses that it have in the response to that message. So it'll gossip around the IP addresses that they have, and eventually it will converge. Even for really big clusters, it will converge pretty fast actually. Because it's doing this. So that was the reason why we only needed to ping one item in the cluster, because eventually it will piggyback the IP addresses to all the other clusters, and everybody should know about everybody else. So basically everybody ping this, and then this piggyback the IP addresses to the other one. And this might work in a way because when this sends a message to this node, it needs to know what IP address and port number it should use when you want to send a message to this node. And that is what topology management is about. And this might seem trivial in a way, because why don't we just use the IP address that we received the message on? And the first problem with that is that there's a difference between in ports and out ports. So even though you receive a message on a port here, you won't be able to respond maybe to that on that port, because it's like one-way direction or whatever. And here we use TCP, so we have an actual message up and running, but as soon as the message is done, the connection is closed, because you don't want to have open sockets like this. You might have a lot of nodes in your cluster, and you don't want to have all these sockets up and running. And in many systems, you won't even use TCP, because you would use UDP instead, because of efficiency reasons. So if we take a look at how this actually works, we kind of touched on the topics in the previous video, or accidentally got into this topology monitor. So you can see on the when we receive a ping message here, we have this topology manager. That is this class right here, or this module right here. And what you do basically is you take the topology that you get piggybacked on the ping message, and then you merge it with your own topology. So that is what you do. And then you respond to that topology manner with the topology, right? And that is how we gossip around the topology. So eventually everybody will do this merging. They will merge the topology that they get from the other ones, and they will know about each other. But there might be some issues with this, because you might be behind some NAT, or you might have different IP addresses like locally, and then you might have some public IP addresses and everything. So the implementation that is being used in this is pretty naive actually. And I really suggest that you take a look at this paper called Shuffling with a Croupier. Croupier is one that deals the card at blackjack or whatever. And this is written by one of the professors that I have at the university, and you can check out the paper here on IEEE. And this is called Shuffling with Groupier NAT-aware peer sampling. And this considers stuff like when you're behind a NAT, and this is a really good implementation of like something called hole punching, where you sorry, where you would use something called a hole punching in order to get through this NAT. All right, so that was basically it for this video, and I just wanted to mention it, that this is also a thing that you should be aware exists. And I hope you guys enjoyed this video, and I will see you in the next one. See ya, bye-bye.